Now let's look at the final type of number as it relates to number theory. And this group of numbers is a special type of, it's a special set of numbers that we're going to be looking at. It's called real numbers. Now, real numbers are, this is just my definition of real numbers. This is the essence of what it is. These numbers are all the numbers that exist on the number line. Okay, that's just a simple definition. However, in books you may see definitions that are a little bit more profound. You will see all the numbers that corresponds to a coordinate of a point on the number line. If you're not sure about what a coordinate of a point is, we would have already covered that in the playlist on fundamentals in mathematics or fundamentals in math or math basics. You could go back to review those lessons and look at the different names of the different parts of the number line, and that should clear that up. Now let's continue with this lesson quickly. Now let's say here to express what we're speaking about when we're talking about real numbers. Let's say I have a number line here, and on my number line, let's just start out by saying this is, let's say this is -3. That point is -3, then this point would be -2. Obviously I'm going down, okay, -1, I'm going up by 1 unit. This would be 0, this would be 1, this would be 2, this would be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and let's just put the final one, 13. Well, obviously we would be going down to negative infinity here. So I would have a negative infinity going in that direction, and I would be going up to positive infinity. This is just an area on my number line that I've captured. Now, let's just quickly look at some stuff here to show you what is really happening. Now, if you look on my number line, you could use this number line to represent counting numbers, where we started out when we, if you have been watching the playlist from the start, where we were speaking about the first type of numbers where counting numbers are natural numbers, and you could actually graph on this number line. We would start at 1 and we would go to 2, 3, 4, 5. But if you notice, when representing counting numbers, and we would be increasing in this sequence. Okay, now all these numbers would be counting numbers that I am circling on my number line. Okay, so earlier when we were asked to, when we were given the definition or teaching about counting numbers, if I should ask you to graph those numbers on this number line, the numbers that I've circled here would represent counting numbers. Now, if I should ask you, but look carefully, if you notice when I was graphing the counting numbers, after I've circled 1, I skip out some values in between 1 and 2, and I went straight to 2. Also, I skipped out some numbers between 2 and 3 and went straight to 3. Okay, so I mean I'm basically jumping from 3 to 4, 4 to 5. So there are some values that are found in between that we basically skipped out. Okay, now if we're asked to graph whole numbers, all I would have to do, I would just have to add 0 to these numbers to get my, and let me just add it here. Let me use another color. I would just have to circle 0 there. If you notice, I have circled 0 there. Okay, so if I circle 0 now, then 0 added to the counting numbers would have given me whole numbers. Now, if I asked you for my integers now, all I would have to do is to circle the negative values here. Okay, so if you notice, I'm circling my negative values there, and I would have gotten my integers now. So all these numbers now that I have circled, everything in combination would be integers. But again, if you notice what is happening, there are some values in between that are not represented. Okay, so in speaking about real numbers, right, and I can just do one thing to show you what I'm talking about. If I say use this number line to represent real numbers, what I would have to do, I would would have to draw a straight line above my number line to show you then that I am not skipping out any values when I'm speaking about real numbers. So all these numbers here would be classified as real numbers. Okay, and pay attention to this quick illustration now that I'll be doing to even bring more clarity or to make the lesson a bit more clearer. Let's say I had a microscope. Let's say I had a, not a microscope, but a magnifying glass. Okay, let me try and find a nice color to represent this. Okay, now let's say I had a magnifying glass, and now let's say I had a magnifying glass, and I took my magnifying glass and I placed it over this region on the number line between 3 and 4. So let me just draw that quickly. Oops, let me change that color. That's an ugly color. Let's say I am circling this area here. This area that I'm circling between 3 and 4, okay, on my number line. So let's say that's my magnifying glass. Let me draw the handle. So let's say that's my magnifying glass, and I've blown up this region here on the number line. Now, if I should blow up this region on the number line between 3 and 4, then there are some values that lies between 3 and 4 that I would have to capture between here, this region here, okay? Between that region that I have colored in black, there are a lot of values between there, and I'm going to show you those values on my number line down here. So if I should graph that and represent those values on the number line that we aren't seeing with our naked eyes now, then down here we would have, let's say for example, this point is 3, this 3 here, then between, when I move up another unit, then I would have, maybe I would have a 3.1 there, then I would have a 3.2 there, then I would have a 3.3 there, 3.3, then I would have a 3.4 there, then I would have a 3.5, 0.5, then I would have a 3.6, then I would have a 3.7, then I would have a 3.8, then I would have a 3.9, then I would have, after 3.9, I would reach my 4. So if you look carefully, between 3 and 4, there are a lot of values that exist between 3 and 4, and we have represented them here on this number line. Now and that's just one quick illustration of what we're speaking about, real values, that there are values that we can't see that lies between infinite number of values. Now let's even make it a bit more interesting. Let's say sorry about that. Let's say I took my magnifying glass again and I blew up, and let's say, let me change my color again, and let's say, let me get my pencil. So let's say I blew up the between 3.2 and 3.3. So let's circle this region here on my number line again, okay? This region here between 3.2 and 3.3, and this is my magnifying glass. So let me draw my handle there. Okay, let's say I place a magnifying glass over this region between 3.2 and 3.3, and I blew that up again. Now this here that we have, it could be represented on our number line pretty clearly, okay? So here now, this point here that I have here, okay, let me just pull this down a bit to show my arrow, to show that that region here, I'm representing it on this number line. So here I would have a 3.2. So essentially here I would have my 3, oops, that color is bad. So here I would have my 3.2. That's a 3.2 there, but this is really 3.20 if you look carefully. Okay, it's the same thing. Now here I would move up to 3.21, then 3.22, then 3.23, then I would have a 3.24, then I would have another 3.25, then 3.26, then I would have a 3.27 at that point, then I would have a 3.28 right there, then I would have a 3.29 right there, then I would have a 3.3 right there. And if you notice, it's between 3.2 and 3.3 that I'm representing here. So between, again, and let me just color this quickly, between 3.2 and 3.3, right, between this region here that I'm coloring right there, there are infinite number of values that are still there between those two, between these two units right here. And again, if I should do the same thing for between, for example, 3 point, so let's say I did the same thing between 3.22 and 3.23. Let me change my color. Let's say, I think you should be getting the general idea that it doesn't matter how much I blew up my number line, I will be getting smaller and smaller values. So if I should take another magnifying glass and blow up that region there, I could represent that on this number line down here. Okay, so here, if this is 3.22, then my first point here would be 3.220. Then I would have a 3.221. Then I would have a 3.222. Then I would have a 3.223. And I think you should be getting the general idea of what is happening. 3.224, then 3.225, then I would have a 3.226, then I would have a 3.227, then I would have a 3.228, then I would have a 3.229, then I would have a 3.23. Okay, and if you notice, I have a 3.23 here where I would stop. So you should get the general idea now that it doesn't matter how. And remember now, it is this region that I've just blued up on my number line. This here that I'm coloring again in blue, that region between 3.22 and 3.23. So that's what we mean by real numbers, that it doesn't matter how small you get on the number line. It doesn't matter how you blow it up. There are values that your naked eyes cannot see on the number line. Okay, so when we're speaking about real numbers, we're speaking about every number that exists on the number line, both negative and positive. It doesn't matter. All right, so that's it. Hopefully you get the general idea. If not, you could always feel free to leave a question or a comment, and we'll get back to you as soon as possible. Bye bye.